Hi, I'm Jared Bailey. I want to talk to you about the post-stroke monitoring rehabilitation system using Kinect, and Gulshan Aggie was my supervisor for this semester. So, stroke incidence is increasing in Australia, with 1 in 6 people suffering from a stroke in their lifetime, 30% under the age of 65. And rehabilitation is very expensive and time-consuming. Physiotherapy is used to try and overcome the physical problems of a stroke. Similar result can be achieved by using the Kinect motion sensor for Windows. Kinect is a multi-purpose image processing device built by Microsoft. It is able to track the human body at 20 different joints. So, stroke is caused by interruption of blood supply to the brain. It can be due to blood vessel bursting or a clot causing a blockage. It often occurs on one side of the body. There's an estimated 62 million stroke survivors worldwide. Greater than 50% dependent on others for everyday activities such as brushing teeth. Upper limbs are more often severely impaired due to it being supervised by a large area of the brain. Reduction in shoulder abduction and adduction. Clinical rehab is required, and upper limb recovery is important to ensure independence in daily life. The Kinect is a motion sensing device that was originally designed for the Xbox 360 gaming console. It provides a natural user interface for interaction using body motion. Has begun to be used in education and medical fields. Kinect for Windows is specially designed to help developers to write their own code and develop real-life applications with human gestures and body motion. There's been an increase in the use of game controllers, especially Microsoft Kinect, as an interface for home-based rehabilitation exercise tasks for stroke survivors, as I'll show you soon. This allows for therapy to be financially accessible to a large population of patients. No other accessories such as handheld controllers are required for the system, which is believed to significantly reduce musculoskeletal injuries. So, post-stroke exercises. Motor function rehabilitation exercises post-stroke largely revolve around strengthening muscles and retaining sensory motor function via repetitive movements. The main goal of post-stroke rehab is to improve the activity of daily life. Upper limb rehabilitation in the form of a shoulder abduction is an ideal exercise for a post-stroke patient to perform. Project development, talk about hardware, exercise design and software. Hardware. So here's an illustration of Kinect showing all sensors, etc. So at the bottom in the base there's a motor with a tilt. In the body you've got infrared emitter, LED status light, color camera and infrared depth sensor. So here's illustration of how the infrared sensor works. So infrared emitter emits light at a certain shape. Infrared light reflects off different surfaces. As this occurs, the infrared depth sensor reads this and produces an image such as here on the right to depth data. Exercise design. To ensure stroke patient was gaining improvement in flexibility and mobility, the correct form and type of exercise had to be designed to ensure encouraged movements were not resulting in harm or further damage to the stroke sufferer. Since stroke patients suffer largely in fine motor aspects such as moving fingers, a larger compound exercise was chosen to develop a sound level of strength. The shoulder abduction exercise was chosen. So shoulder abduction is just simply move your arm up to the side. That involves the patient moving the arms laterally from the side of the body up to shoulder level in a smooth tempo to avoid injury. Rating performance. So needed a way to rate the patient's performance in the application. So the patient receives a rating on the user interface informing them of their range of movement. So they get a rating of poor if they're from 0 to 22.5, average 22.5 to 45, good 45.1 to 67.5, and excellent they achieve 90 degrees or in between 90 and 67.6 degrees. Software. Kinect Windows Software Development Kit or SDK. Kinect Windows SDK provides a set of APIs allowing easy access to skeleton joint data. Each joint position is identified by its name, so head, elbow, shoulder, etc. It has tracking states of tracked, not tracked, or position only. So here's an illustration of all the joints in standing or normal mode, and on the right here is a listing of the joints that can be tracked in seated mode. Reference bone, so on the left was the normal configuration of how it was set up. I've added in here a reference bone, so it attaches from the left shoulder to the right shoulder. So when the patient attempts to do the shoulder abduction movement, if they get their left arm in a straight line all the way through the reference bone to their right arm, it'll be pretty much a perfect movement. Feedback, so the user interface provides feedback to the user. So you can see here the user's right hand is out of frame, so it colours that side red, and their feet are also out of frame, so it tells the user to move to the left and backwards to get the whole body into the frame. Angle algorithm, to assess the patient, angle between the arm and body needed to be calculated. So it was calculated using simple trigonometry with the joint coordinates and inverse tan function. So just get the difference in the two X joints from here to here, and then two Y joints, and just inverse tan to get the theta, which gives you the angle in degrees. User interface, so here's the user interface here. On the right, it's got left arm angle with showing the angle, the rating, and here's the right arm angle in degrees with the rating also. Down here on the left is a little seated mode button. You press that, it goes into seated mode instead of standing mode. Results. Yeah, so here's the results. Patient receiving a grading of poor with an angle reading of approximately 18 degrees for both arms. Here, reading of average, rating of about 40 degrees. Here, rating of good, with angle of about 50 degrees, and over here, rating of excellent with angle of about 90 degrees, which is what you want the user to achieve. So this is a seated mode, so only these are just the joints as you saw earlier that it records. Patient receiving poor, left arm, right arm angle about 13 degrees. Here, excellent, angle of about 90 degrees. So conclusion, post-stroke monitoring rehabilitation system using Kinect has been successfully applied in the field of rehabilitation for stroke patients. They can recover in comfort of their own home at a fraction of the cost of, say, a physiotherapist. Recommendations for future continuation: more exercises, categorized in particular muscle groups, so you can target a specific muscle or area. Assessing more angles, so not just a single angle, like elbow angles as well. And test on actual stroke patients to improve its validity. Thank you.